one of the interesting problems that we run into with integration by parts is what do we do if we end up with a couple of parts in our integral that are going to start repeating? And we'll notice that this is certainly the case right here. We've got e to the negative x times sine of x dx. How are we going to handle this integral? Well, to picture what's going to happen right here, of course, let's just go ahead and make a selection. We're going to make u equal to e to the negative x so that dv will be equal to sine of x dx. All right. Well, what does that mean for us? Of course, du will be negative e to the negative x dx, and v will be the negative of the cosine of x. Right? Remember, change the sign as you go from sine to cosine. So we're going to end up with this expression for our integral of e to the negative x sine of x. By the way, you'll notice that I'm writing this whole expression out. There'll be a reason for that in a minute. So what happens? We end up with this expression right here, u times v, so negative e to the negative x times the cosine of x minus, and then it's v du, so v du minus, we've got a negative cosine of x and a negative e to the negative x, so minus e to the negative x times cosine of x, right? Those two other negatives cancel out, dx, all right? And now we've got another substitution integration by parts problem, right? Now, potentially we could set up a table and just kind of follow along, see what happens, but we're just going to need one more iteration for this. I'll show you why. So in my next step, I'm going to let u, again, equal e to the negative x. But this time I'm going to take du, while du will still be negative e to the negative x, just like we did before. But this time we've got dv being replaced with cosine of x dx, and that's going to give us v equaling sine of x. All right, so now when we make our replacement, we're going to have essentially the same start for our expression as we did before, but this time we're going to substitute in with our new integration by parts. So it'll be the new e, u times v, so that's going to be e to the negative x times the sine of x minus the integral of, what do we have right here? It's going to be let's see, v du, so that's minus e to the negative x times sine of x. Oh, sorry, there's a dx right here. Negative e to the negative x dx times sine of x, so that's a negative. So this is going to become plus the antiderivative of e to the negative x times sine of x dx. And well, we've actually seen that e to the negative sine of x dx somewhere before. Well, there it is, right? We just ended up back where we started with. What do we do? Well, let's rewrite this thing one more time here, and I'm going to distribute my negatives to make sure everything looks right. So let me straighten this out a little bit. And you can see that once I've distributed my negative sign right here, I'm subtracting this quantity from the left and this same quantity from the right. I'll highlight them, right? This guy right here is exactly the same as this guy right here. And when we have that situation, what we can do is we can add that quantity to both sides. So look at what happens when I add this to both sides. We add that same quantity to the left as we do to the right, and when we add those, well, now we've got two of them on the left. We now have 2 times the integral of e to the negative x times the sine of x dx equaling this quantity that's left over. And so, of course, the answer to solving this equation is to divide both sides by 2 and get our new expression, which isn't too bad. And we could actually factor out negative e to the negative x from all of this and get this simplified expression. And of course, since this is an antiderivative and not a fixed derivative, we're going to say plus c at the end in order to make that work. Now, we probably could have said that right here and then divided everything by 2. We still would have ended up with the same kind of expression. It's just a constant. So there we go. This is our antiderivative, and that's what we wanted, and so we're done. Good luck with your homework, too.